For lesson 3 and lesson 4 in unit 4, we're going to learn a couple triangle congruence shortcuts. Now this quick lesson just focuses on side angle side and side congruence shortcuts. We're going to use those shortcuts instead of having to show that all 6 pairs of corresponding parts are congruent. We are going to know that with triangles we can kind of take a little bit of a shortcut here and we can use 3 pairs of corresponding congruent parts. And so the first theorem here is theorem 4.3, the side angle side congruence. So that's what SAS stands for. If you have 2 sides, 2 pairs of sides congruent, and the angle that's included between those 2 sides congruent between this pair of triangles, then that means the triangles are congruent. This doesn't take too much to really understand and believe, but we could translate this triangle just so that it is a reflection of the other, and we would note that if we have these segments arranged in this fashion, separated by that angle measure, then there's only one triangle that can connect the endpoints x to z, the same segment that would have the same length from r to t. All right, and so this is a side angle side where the angle is included between the pairs of corresponding sides. Right? When we are talking about included angles or included sides, we want to make sure that we are understanding that language. I don't want to go so far as to say that this is vocabulary, but it is a concept that when we talk about the included angle, we need to know what that is. All right, so in this case, we have this side marked and this side marked. What is the angle that is included between these sides? Hopefully you're going to be able to tell me that J is the angle that is included between those sides. Another way to understand that is that segment JH and segment JK, they share the angle at J. JH, JK, the angle at J is the included angle. How about this one? Here, you should note that between segment ED and segment EC, we have the shared angle E. If we're repeating that point E, then we know that that is the included angle between side ED and EC. Okay? All right. Now this statement right here is called CPCC. Now I am okay with us not writing CPCC because sometimes we get the letters confused. And instead, we can use what we would call the definition of congruent triangles. So by the definition of congruent triangles, if we have congruent triangles, then we know that all of their corresponding parts are congruent. Now you might be saying, like, I know we already talked about that in a couple lessons ago in lesson 4.1. We showed congruent figures have all their corresponding sides congruent and all their corresponding angles congruent. So you telling me this, Mr. Hibbett, isn't new information. It's just a new abbreviation that is confusing, right? So if you're confused by the fact that corresponding parts of congruent triangles are congruent, let me kind of explain why we have this application. When we use side angle side or side shortcut or some other shortcut for proving the triangle is congruent, we are only using 3 pieces of information out of the 6 pairs of corresponding congruent parts. So if we're using side angle side, I've used 2 pairs of congruent sides and 1 pair of congruent angles, but I have another pair of congruent sides and I have 2 other pairs of congruent angles. So I can use the fact that the triangles are congruent, now that I've proven them congruent, to show that the other 3 pairs of corresponding parts are also congruent. So that's why this becomes useful. It kind of seems like a non sequitur in the middle of the conversation, but that is how we will apply CPCC. Now side congruence. SSS is what our shortcut is here. We'll just write SSS. Meaning that if we have this pair of sides congruent and this pair of sides congruent and this pair of sides congruent, then these triangles must be congruent. Right? There's only one way to fit triangles with these side lengths together. The angles would have to be the same measure based on the way that those segments of those lengths will fit together. So if 3 sides of one triangle are congruent to 3 sides of another triangle, those 2 triangles are congruent. But we could then, if we know, hey, pair of sides congruent, pair of sides, the triangles are congruent by SSS. Now by CPCC, or the definition of congruent triangles, I can now say that these angles are congruent, and these angles are congruent, and those angles are congruent. That's not given information, but now that I know the triangles are congruent, I can say that those corresponding parts are congruent. So let's go ahead and take a look. Here's a great proof. We're going to prove that these triangles are congruent. We're going to use either side angle side or side side side. We are given that JK and LM bisect each other. JK is this segment right here. LM is that segment right there. And we are told that they bisect each other. So here is the subject, here is the verb, and these are the direct objects. Each other are the direct objects. So this one bisects that one. It means it cuts it in half. And likewise, this one bisects that one. It cuts it into congruent parts. So that means that this part of JK is congruent to that part of JK. And this part of LM is congruent to that part of LM because those segments bisect each other. Our job is to prove that these triangles are congruent, and we're going to do that not using side, side, side. There's not a third sides theorem, all right? Like there's a third angles theorem. There's not a third sides theorem, but we do have something, a freebie here. One of our freebies that we talked about the other day in class was the vertical angles theorem, right? We should be able to see that we've got a pair of vertical angles. I don't have anything marked parallel, so I don't know that anything's parallel, but I do know that these are vertical angles, and therefore those angles around point P are congruent to each other. So let's do these freebies. Let's first list the given information that JK bisects LM. This means that these parts of LM, PM and LP, are congruent to each other, all right? If JK bisects LM, it means that these two parts are congruent by the definition of bisect. Since LM bisects JK, we know that these parts, PJ and PK, are congruent to each other, all right? So we have a pair of sides, and now we have this pair of vertical angles. So we have side, angle, side. It looks like it says side, side, and then angle. And so what we want to make sure we understand is that we have two pairs of congruent sides and the included angle. And so that's how we know that we have side, angle, side congruence for these triangles. Now again, think about how we do a proof. This is given information. Now if you said this as just one statement and then these as two separates, that's fine. All right? So this is free. Definition of bisect is a freebie also. Vertical angles is a freebie. And then knowing that we have two pairs of sides in the included angle, side, is hopefully going to be, it's going to feel like a freebie by the time that we're done with this unit. So there really wasn't much thinking that's involved with this if we know what bisect means, if we know how to read the sentence, and if we understand the vertical angles theorem, all right? So this could be a quick, easy, done proof in 4, 5, or 6 steps. All right? Oh, here's another way we could say it. Yeah, so I didn't know. I was like, why is this on again? Because we can have it with them bisecting each other and then list two of those points or two of those statements by the definition of bisect. And therefore we have then vertical angles and then side, angle, side. So we could do this, like I said, in 4 steps instead of having to write these things out separately as separate steps. All right, let's try this one using side, side, side or side, angle, side. Well, in this case, we know that we are given, in the diagram, it's not a given statement, but we do know that ML and PN are congruent. We know that MN and PL are congruent, all right? So these are given congruent, these are given congruent. Those are freebies. That's the gift. That's an easy couple points on this proof, all right? Now, I would need to say that these angles are congruent if I was going to use side, angle, side, or I would need to say that this side is congruent to itself if I'm going to use side, side, side. So we can use some deductive reasoning there to say, hey, that side is congruent to itself by the reflexive property of congruence. Again, a freebie there. That thing being congruent to itself is free information. And then that means that these triangles are congruent by side, side, side. So what I want to encourage you with is don't shy away from these proofs, all right? I promise that if you try them, you will get them mostly correct, all right? Mostly correct. Now you might stumble here and there, you might not see the reflexive side, but hopefully through practice we're going to open up our eyes to be able to see those things. All right, this is an important question because a lot of the work that we do is going to involve looking at pictures where maybe not everything's marked, maybe not everything's explicitly stated, and we want to make sure that we have enough information, or do we need to deduce other information? So do we have enough information to prove that these are congruent? Yes, we do. We have a pair of sides, a pair of sides, a pair of sides, so these triangles are congruent by side, side, side. Over here, I have two sides and the non-included angle. If these angles were congruent, then I could go ahead and say, yes, these triangles are congruent. but there's no ASS, right? We don't have that as one of our theorems, as one of our shortcuts. And so we can't say that there's enough information here to prove these triangles are congruent. Over here, we've got two pairs of congruent sides, and the angle included between those congruent sides is also, that pair of angles is also congruent, so we can say that these triangles are congruent by side angle side. This one, same deal. Two pairs of sides, and then the included angle. So we can say side angle side here. We want to be careful of that ambiguous case where we're not quite sure if those triangles are congruent. They do look congruent. That doesn't make it so. And just because we can't tell or we can't determine with this information that they're not congruent doesn't mean that they're not congruent. It just means that we don't have enough information to definitively say that they are. All right, so another spin on that same example, that same idea is, what would we need to prove these triangles congruent by side angle side or by side side side? And so there's lots of different ways that we can approach this. I'm just going to do a couple of these just because for time's sake, I don't know if that's necessary. We're given this information and we have this reflexive side. So for this first part, let's call this A and let's call this B. For this first part, I would say for 4A, if I want to do side angle side, then I would need to know that this angle that's included here and this angle there are congruent. Now I can say that a couple different ways. We would need to know that angle RSK is congruent to angle TKS. Or if they told us that these lines were parallel, RS parallel to KT, then we could use the alternate interior angles theorem. So there's two pieces of information that we could be given, either explicitly that these angles are congruent or explicitly that these lines are parallel and therefore we know that these alternate interior angles are congruent. A couple different ways we could do that. Or for part B, what we would say here is for side side side, we would need to know that these short sides are congruent to each other. We need to know that RK is congruent to ST. All right, over here, this is kind of like a pair of overlapping triangles. And so based on this information, I know that this segment is congruent to itself. So if I wanted to do side angle side, I'd need to know that this angle and that angle are congruent. Go ahead and write those down, name those angles. If I wanted to do side side side, I'd need to know that this segment here, BD, is congruent to that segment there, AC. All right, and that would show then that these two triangles are congruent. All right, see if you can do something with this third one. See if you can think through how to do that with the triangle WXY and WZY. All right. And then after you've done that, I would love for you to try to do this proof. All right? There is enough information here to show that these triangles are congruent. You are given that FG and KL are parallel. You are also given that FG and KL are congruent. Just because they're congruent doesn't make them parallel. Just because they're parallel doesn't make them congruent. But in this case, they are both congruent and parallel. So let's see if we can prove triangle FGK and triangle KLF congruent. Pause the video while you do that. And then that should put us to the end of our instruction. Please see me in seminar or ask questions if you have any.